treated? Well, with AFib, if they're not right in sync, they treat it like this. First of all, the doctor will want you to take some Coumadin. And he'll want you to go in for a PT time, prothrombin time, about every week and a half. Go to Quest Laboratories, get a PT, have it sent to them. And now, why do they take Coumadin? Don't want the blood to clot. If the atria are doing this, blood might tend to clot in those atria. And if a blood clot goes from an atria into the ventricle, they worry mainly in AFib, y'all, they worry about strokes. Like a blood clot in the brain. Say a clot forming here, pooling around in the atria, going to the ventricle, going to the lungs. Sometimes it can cause a pulmonary embolism. Going to the lung, back, so forth, getting the circulation, end up in the brain and cause a stroke. That's serious stuff. That's very serious stuff. So anyway, there's that right there. Kind of interesting to see that. QRS wave, that's ventricular depolarization, spread through the electrical impulse through the ventricles. The ventricles contract. That's the QRS. All right, and then the T wave is ventricular repolarization. And as I said, you don't see the atrial repolarization because the activity of the ventricles is so strong. It's like when you look outside and you see the green grass. There are other pigments in grass and in leaves. There are other pigments, but they are M-A-S-K. They are masked by the green because it's so strong. Okay. And so it's out there. The green covers things, but there are carotenoids and xanthophylls. There are yellow pigments. There are orange pigments. You don't see them. Well, this ventricle, the ventricular activity is so strong that it masks, it covers up the atrial repolarization. You don't see it. It's masked. Okay, so that T wave, everybody, ventricular repolarization, the ventricles then are going into diastole. They're beginning to relax in repolarization. All right? Now, no deflection wave to show atrial because the stronger QRS masking covers it up. It hides it because it's so strong. So we don't ever worry about that. All right, now right here, wave variations. Okay, now this is one of the things that they will look at. Remember we talked about other things too, in the myocardial infarction, those enzymes, the enzyme activity. All right, a P-wave enlargement indicates enlargement as in a mitral stenosis. P-wave enlargement can do that, a P-wave enlargement. A P-wave enlargement also, and I didn't have this up there, in your book, the P-wave enlargement can also indicate, in fact it's in your textbook, can also be an indication of, and I didn't put that on there, you might jot it down. I just forgot to put it on there. It's in your textbook if you have it. A P-wave enlargement can also indicate an MI, myocardial infarction. Just kind of jot that down if you have your notes. It can, I didn't put it there, but it can indicate enlargement as in mitral stenosis. It can do that, but it can also, according to your textbook, because I was looking at that while y'all were taking the lab, like you saw me get out one of the texts that we kept keeping that drawer up there, and I was wanting to check that on that P-wave enlargement. All right, but it can do that. All right, now right here, a Q-wave can also, so there's several indications of an MI. A Q-wave, here's the Q-wave enlargement, would be where this one right here dips way down. That can indicate, in other words, everybody, if a person has a heart attack and survives that heart attack, it will show up on an EKG. It will show. It will show in some form or fashion if you had a heart attack. Yeah. And so when I had the coronary artery blockage, I did not have a heart attack. I did not have an MI. But I did have some coronary blockage. And the nuclear stress test, the nuclear stuff will show, the nuclear stress test, Kimberly, will show if there's any necrosis of any area. In other words, if any dead muscle area in the heart. It'll even show scars, scar tissue from death of tissue, myocardial infarction. And I looked at it, I didn't really have any problems with the heart muscle. I really didn't have any issues with that at all. But I did have some blockage type stuff years ago. And so we dealt with, you just deal with it. You move on. You move, just kind of go on. All right, but anyway, right here, the ST segment, elevated in an acute myocardial depressed. Now, this is what we find a lot, everybody. And see, if I had really been thinking about this 13 years ago, if I had 13 or more years ago, if I'd really been thinking about this, see if I'd really been into, I was teaching anatomy, but I really, you know, I wasn't really thinking about this that much when I was dealing with I would have said, well, right now, I would ask about the ST segment. I would say, doctor, whoever that doctor was over there that first did the stress test, I'd say, well, is the ST segment depressed? Or what? What? So I would do, you know, I would ask that. You know, I would just check on the ECAT and say, how do you suspicion? What is your indication? And I would ask him that. Okay? But anyway, there's the thing. And so there it is. Now, heart blocks. A heart block is a faulty conduction. That is a heart block. A faulty conduction. And that's what with AFib, there's a partial block. There's in VFib, there's a block. Faulty conduction. Conduction where? From the SA to the AD. Most faulty conduction problems, so I understand, begin at the AV node. Most of them do. But again, that can vary a little bit. So heart block. Now this is probably new to you unless you've dealt with somebody who they say he's got a heart block. Unless you've dealt with somebody. First degree heart block, characterized by a PR interval greater than 0.2 of a second. Now this is where, everybody, this is where you need, now let me show you. The first degree heart block, from the beginning, now when you print this out, from the beginning of the P wave to the beginning of the QRS, it's greater than 0.2 of a second. You kind of follow what I'm saying? That indicates a first degree heart block. From the beginning of the, in other words, was first degree, characterized by a PR interval, or PQ, PR interval, from the beginning of the P wave to the beginning of the QRS, the PR or PQ, greater than 0.2 of a second. Now, how do you know 0.2 of a second? Remember, each of those little bitty blocks are 0.4 hundredths of a second. All right, and so there's the first degree. First degree. Now, I have a note right here. The PR interval is the distance from the beginning of the P wave. In other words, now follow me. You can see that I don't have the drawing of the little blocks up here. But from the beginning of the P wave, from right here to the beginning of the QRS, if that's greater, now from right here, now those little blocks are like this. Okay, I'm just this chord. Now I'm making it, it's going to be really exaggerated here. But here are these little blocks, 0.04 hundredths. All right, we have 0.04 times 1, 2, 3, 4, 5, 6, 7. Say 8. 0.04. 0.04 times 8 would be 0.32. That's greater than 0.2 of a second. You follow me? Kind of get the drift. Greater than 0.2 of a second. Now they say people can live with that. They say, so I understand, you know, just deal with that one. So I understand that one's not a big. So you know, and again,